Yo, welcome back. We got we're on lesson 2, multiply powers of 10. Let's explore patterns with exponents when we multiply powers of 10, 10, 1, or 1/100th. Claire says she sees 100. Tyler says he sees 1, and Maya says she sees 1/100. Who do you agree with? All right. Take a look at that. Well, I guess it depends. Depends how you're looking at it. Alright, so if you're looking at the whole entire grid as one complete unit, if you're looking at this whole entire grid, you could see it as 1. If you're looking at each individual box here, you could see it as 100. Alright, and if one of these was shaded in, something like that, if one of these was shaded in, you could think of it as 1 out of 100, which would be, I guess, May. That's how May would see that. So depending on how you look at it determines on who you may or may not agree with. Alright, I guess right here, just for clarity, start down here. This is if you're looking at one square. As one complete unit. And as a group of squares, as a group of 100 squares. Alright, and then you could say down here, it depends. Alright, put that in your notes. Get ready to move to the next. Alright, let's move on to the next question. Go ahead and read that question. See if you can solve it. And what I would do is like draw a line here. And then on the left, you solve it, and then on the right, we'll go over it. So take a minute to go ahead and do go through the first, and for that fact, you can I think you can go ahead and do, yeah, just do 1 and 2 on your own, but leave space for your notes. Alright, so it says here in the diagram, the medium rectangle is made up of 10 squares, so that's here. The large square is made up of 10 medium rectangles. Okay, so there's 10 of these. There's 10 of these right here, all the way across. How could you represent the large square as a power of 10? So this one would be 10 to the first power, and then this one, the median, will be 10 to the first power times 10 of them, so that's going to equal 10 squared. And this, there's 10 of these medium rectangles, So then that's going to be 10 squared times 10 to the first is going to equal 10 cubed. For the large, the medium, and the small. Alright, so that's for question 1. How would you represent the large as a power of 10? And that would be 10 cubed. If each small square equals 10 squared, then what does the medium rectangle represent? Okay, so they complicated it. So then if this now starts at 10 squared, then this is going to now be 10 squared times 10 to the first, and now it equals 10 to the third. Okay, so I guess this is the second scenario. This is the second scenario, and now we have 10 cubed times 10 to the first equals 10 to the fourth power, and this is the second scenario. Alright, so the medium would equal 10 to the third, and the large equals 10 to the fourth, and this one is the large for this question. Alright, go ahead and put that in your notes. And let's go on to the next question. Boom. Question 3 and question 4. If the medium rectangle represents 10 to the fifth, then what does the large square represent, and the small? If the large square represents 10 to the 100, then what does the medium rectangle represent, and then the small? So again, go ahead and split these sections in half and go ahead and try to do the left on your own, and then we'll come back and do the right. Alright, if the medium rectangle is 10 to the fifth, okay, what does the large? So that would be 10 to the fifth times 10. You know what? Alright, I keep it going. Hold up. I wanted to say large, so we know what we're talking about here. So we're going to have 10 to the fifth times 10 to the 1, which is 10 to the fifth plus 1, 10 to the 6th for the large. Okay, and then for the small, it's going to be 10 to the fifth divided by 10 to the first, which is 10 to the fifth minus 1, which is going to equal 10 to the fourth for the small. Alright, go ahead and add that to your notes. It says if the large square is 10 to the 100, what is the medium? So we want to do medium, and that is going to be 10 to the 100 divided by 10 to the first equals 10 to the 99th power. Alright, and then the small is going to be 10 to the 99, because that's the medium. Then it's going to be divided by 10 to the first, which equals 10 to the 98th power. Alright, so basically, let's say summary. When you multiply by 10, you add an exponent. Okay, or larger. Hold up. Multiply by 10. That's when you want to make it larger. Let me see. I'm going to say larger. Plus 1. And we're talking about exponents. Alright, and when we divide by 10, because we want it smaller, then we subtract one exponent, just to clarify that. Alright, and they might say that in the summary, but I want to add that to this question. Alright, go ahead and add that to your notes. Then we will move to the next section. Alright, multiplying powers of 10. Complete the table. Explore the patterns of exponents when multiplying by powers of 10. You can skip a single box in the table, but if you do, be prepared to explain why you skipped it. Alright, so you're going to have, this one is going to be 10 to the 7, because you got 10 times 10 times 10 times 10 and 10, 3. Alright, this is going to be 10 to the 8th, and 1, 2, 3, 4, 1, 2, 3, 4. This is 3 and 5, so that's 10 to the 3rd and 10 to the 5th. It's also 10 to the 8th, and this is okay, so you probably would skip this one because it's not very user friendly. Alright, so we got 18 plus 23. Alright, so 10 to the 41st power. Okay, so I don't know what to put in there. Not possible. Or let's say doesn't fit. Does not fit. If you choose to skip, which entry? the last, because it is impractical. How about that? How about we say impractical? And the pattern is clear. All right. Pause right there and move on to the next. Alright, use the pattern you found in the table to write 10 to the nth power times 10 to the m as equivalent, like 10 to the blank. So 10 to the n times 10 to the m equals 10n plus m, which equals, oh, well, that's it. That's all. Alright. Use your rule to write 10 to the fourth times 10 to the 0 with a single exponent. What does this tell you? Okay, so that would be 10 to the fourth times 10 to the 0 equals 10 to the fourth plus 0 equals 10 to the fourth. So that tells you that 10 to the 0 is the same thing as 1. Alright. So any number with power of 0 except 0 itself equals 1. And I needed a parenthesis there. Except 0 itself. Alright, and just for clarity, so for example, 10 to the 0 equals 1. 5 to the 0 equals 1. A negative 3 to the 0 equals 1. 1,000 to the 0 equals 1. But 0 to the 0 equals undefined. Does not equal 1, and it will be considered undefined. Alright, so undefined means you can't come up with a clear answer. Okay, it just like it doesn't follow the standard laws or rules of math. Okay, so for example, 5 dividing a number by 0, okay, equals, that's another example of undefined. That's an undefined problem. Okay, so we just can't solve it consistently. So that's what undefined means. Alright, go ahead and put that and make it neat, you know, make it make sense to you in your notes, and keep it moving. Alright, moving on to the next. The state of Georgia has roughly 10 to the 7th human residents. Each human roughly has roughly 10 to the 13th bacteria cells in his or her digestive tract. How many bacteria cells are there in the digestive tracts of all the humans in Georgia? So that would be 10 to the 7th times 10 to the 13th, which equals 10 to the 7th plus 13, which equals 10 to the 20. Alright, let's go on to the next. Alright, so we have, are you ready for more? There are 4 ways to make 1, 2, 3, 4. 1, 2, 3, 4. They say there are 4 ways to make 10 to the 4th power by multiplying powers of 10 with smaller positive exponents. This list is complete if you don't pay attention to the order you write them in. For example, you are only counting 10 to the 1st times 10 to the 3rd and 10 to the 3rd times 10 to the 1 once. So yeah, you can't like switch it around and use it twice. Alright, so I mean, these are called integer partitions. Okay, integer partitions. Alright. So it gives you the options of calculating the number of unique sets or partitions. So we can say that's the number of unique sets. Oops. Unique sets. Okay, number of unique sets. So for example, you could have what are the partitions of 4? You could do 4, you could do 3 plus 1, you could do 2 plus 2, you could do 2 plus 1 plus 1, and then you could do 1 plus 1 plus 1 plus 1. So that's 1, 2, 3, 4, 5 unique partitions. They have, yeah, they don't have 2 plus 1 plus 1. Oh yeah, they do. Well, they don't have 10 to the 4th. Well, anyway, this is what I'm talking about. These are examples of how unique partitions work. So they're asking you for 10 to the 6. Okay, so for 10 to the 6, okay, take a minute and try to list as many as you can. I don't even think there's room for you to list them all. Okay, so just for this, list as many as you can, but I'm going to be able to tell you there's 10 ways. Okay, and for 10 to the 7, okay, 10 to the 7th, there are 15 ways. and 10 to the 8th, there are 22 ways. So there's not enough room on your paper. And like I said, these are called partition numbers. Alright, so like if you went in on Google here, let me delete that. Hopefully this will show up, and say you searched on a partition number calculator. Partition number calculator. Okay, then you clicked on that. I don't know if you can see that. It says partition calculator. Count partitions of, let's say, 7, 10 to the 7th. Okay, and then it says number of partitions 15, and then it even lists some of the ways. It's not a complete list here, but it tells you there's 15 total, and then it lists them out, and it gives you some other information. Okay, so anyway, that would be one way to check your answer. But some additional information on integer partitions. So let's stop here, and from this point on you can work on your practice problems. If you got any questions, ask me in class. Other than that, peace.